In this video, we're going to understand how to plot points on a coordinate plane. So, evidence-wise, we're going to talk about how do you identify which quadrant your point is going to be in, and we're also going to talk about how you can reflect a point across both the x and y axes. So learning experience-wise, we're going to do two mini lessons, one on plotting points, one on reflecting them. There's going to be a you-do problem. We'll review things to remember, and then we'll leave you with some suggested practice problems. So, for ordered pairs, let's talk about what an ordered pair is to start with. So first of all, an ordered pair tells us a position on our coordinate plane. So we see our coordinate plane here. We could have a point somewhere over here. We could have one over here. We could have one over here, or over here. What we know about quadrants is going to help us figure out which quadrant it should be in. In the last video, we talked about the fact that our first quadrant is all positives. The second quadrant has negative, positive, negative, negative, and positive, negative. We'll talk about that more in a sec. But an ordered pair also contains an x and a y value. These are our x and y coordinates. When we write them, we always put our x value first, and we put our y value second. So just to show you what that would look like, you'd have in parentheses x, whatever that is, comma, y, whatever that is. And we'll look at some actual examples that will go on our coordinate plane in a second. So, some examples. We have 2, 3, negative 4, negative 6, and 1/2, negative 3. Let's work on plotting each of those on our coordinate plane. So, 2, 3, we're going to start by knowing which value is our x value. In this case, it's going to be 2, and y is going to be 3. We know this because we always have them in order x, y. We also see that both of these are positive, so that means that it's going to be in our first quadrant, right? So, we're going to start off by finding on our x-axis where we have a 2. And if it helps you, you can put a little dot right where it should be. I don't even know if you guys can see that, really. Just so we know where we are. We then look at our y value. It tells us that we're at 3. So we're going to go up to 3. And our point is going to be right there. Now, it's a good practice to label your points so that if you're looking at them later, you remember what they are. So we can label this as 2, 3. The next point that we have negative 4, negative 6. If it helps, we can again write down which one's x and which one's y. And since they're both negative this time, we know that we're going to be in the third quadrant because our x and y values are both going to be negatives in our third quadrant. So just like we did previously, we're going to go on the x-axis over to negative 4, and then we're going to go all the way down to negative 6, plot our point right there. And it's good practice to label your points. Sometimes you'll have letters to label your points, other times you won't. In this case, we can just write the ordered pair next to the point. Finally, we have 1/2, negative 3. We'll write down our x and y values again. And this time we have 1/2. That's not on our x-coordinate, our x-axis anywhere. But if we remember from when we're learning about number lines, we know that we can put 1/2 right in between 0 and 1, because that's where 1/2 would be on our number line. So we're going to start there. Our y-coordinate is negative 3, so we're going to go down. And then we can plot our point right here. This would be the point 1/2, negative 3. If we look at our x and y values, we know it's going to be in this fourth quadrant because the x value is positive and the y value is negative. Now, we didn't look at an example in the second quadrant, but if you had a point here, your x value would be positive. Sorry, your x value would be negative, and your y value would be positive. So take a minute to write this down if you need. Then we'll talk about reflections next. So when we talk about reflections in a coordinate plane, if you think about what a reflection is in real life, it's basically the same thing. The only difference is that we are always going to reflect across one of our axes. So either across the x or the y axis. When you get further in math, you might do it across different things. Sometimes you can do it over a different line. Sometimes you can do it over an angle. There are a lot of different things you can do. But for right now, let's just focus on reflecting across an axis. If you think about in real life, if you look in a mirror, you see your reflection in the mirror. We are going to work on reflections in basically the same way, but we're going to say that our axes are our mirrors. So for example, let's reflect the point 2, 3 over our x-axis. Now, we plotted this one last time. It was right here. We'll rewrite it just so that we have it. This is 2, 3. All right. So the next step is to identify which axis we're reflecting across. We know from this problem we're reflecting across the x-axis. So that means that we're going to think of our mirror being our x-axis. To reflect it, what we're going to do is we're going to look at the value that does not match the axis. Now, that's kind of a weird thing to think about, but since we are reflecting across the x-axis, we are going to want to look at the y-coordinate. What we're going to do with the y-coordinate is, I don't know if you'll be able to see this, but we are going to find the opposite of that value. In this case, we're finding the opposite of our y value, which is 3. The opposite of 3 would be negative 3. So that's going to tell us our reflected point. Our x value is going to stay the same, so it's still 2. But our new y value is going to be the opposite of our original y value. So we'll go over to 2, and we'll go down to negative 3, and we'll plot our point there. Now we have plotted the reflection, which will be the point 2, negative 3. Now to check your work, there's a great way to do this. If we think about absolute values and distances, if we look at the distance from our x-axis to our point, this is going to be a distance of 3. If we look at the distance from our x-axis to our reflection, it should also be 3. This is really important because that means that our reflection is definitely in the right spot. I don't know if you've ever looked in the mirror at how far away you are in the mirror compared to when you're looking at it, but you'll see the same thing in any mirror. If you go to the bathroom and look there, you move closer or further away, you should be the same distance in the mirror as you are in real life. So, a really handy way to check there. If we're reflecting this across the y-axis, we would do the same thing, but we would use our x value instead. So we would have negative 2, 3, since we would care about our x values since we're using the y-axis. And our point would be here. So, take a minute to write that down. If you didn't write it down, then we'll look at a you-do problem. So in this you-do problem, we're going to use this map. This comes from our Savas resource. And using this map, we're going to answer 3 questions. What landmark is located at negative 0.7, negative 0.2? What landmark is located at 3/10, negative 1/5? And then what are the coordinates of the point that is a reflection of the pond across the x-axis? So one thing to bear in mind with this one is our scale. Each box is going to represent either 1/10 So 0.1, depending on whether you prefer to think about fractions or decimals. Give it a shot. Ready, go. So things to remember: an ordered pair always has an x and a y value. We show this by making sure that our x value comes before the y value. We have them in parentheses. We use a comma in between them. When plotting a point, always start by finding where the x-coordinate should be, and then moving either up or down to the y-coordinate, depending on what it is. When we're using reflection, we're going to use one of the axes. Find the opposite of the other value. So again, if you're reflecting across the x-axis, look for the opposites of the y value. If you're looking at the y-axis, look for the opposites of the x values. And you can check your work to make sure you've done it correctly by seeing if the distances from your axes are the same. They should be exactly the same. And in fact, if you take the absolute value of both of your opposites, those should be the same as well. So write those down if you need. Finally, we come to our suggested practice problems. I want you to create your own coordinate plane and plot the following 8 ordered pairs. The first 4 are all integers, so they'll be a little bit easier to plot. The second 4 are, well, the second 3 at least, have just any kind of rational number in there. Some of them are fractions, some of them are decimals. Do your best to figure out where those should be. And the last one is 0, 5. This one's kind of weird because it's not in a quadrant, but I want to see if you can figure out where that would go. Then you're going to pick one of your points. It doesn't matter which one you want. You're going to reflect it across the x-axis. You're then going to pick another point, could be the same point, and you're going to reflect it across the y-axis. Give this a shot. Good luck.